want to explore this idea about a double angle now. And again, you're looking at these different identities to help us take problems that we earlier couldn't solve and reduce them into problems that we do know. Again, there's an infinite amount of angles, and I only asked you to kind of be familiar with some of them. So when we find angles that are either half of those angles or twice those angles, maybe we can also solve those as well. So we have three double angle formulas up here. Sine of 2 theta equals 2 sine theta, cosine theta, and the other two underneath of that. And how we derive those is it's a matter of taking our, rewriting this possibly as sine of alpha plus beta. And remember that out, that was the sine of alpha cosine of beta plus the cosine of alpha and the sine of beta. And instead of alpha and beta being alpha and beta, let's make them theta and theta. So then I'd have the sine of theta times the cosine of theta plus the cosine of theta equals the sine of theta. And these are the same two terms, so I can rewrite that as 2 of the sine of theta's cosine theta. And so that's how we kind of derive the double angle formulas. And this process is similar to finding the double angle of cosine and the double angle of tangent. So let's look at another problem that we have here of how we can use these types of ideas. So let's say that I have a model described by here. I have some angle, theta, and I'm given that its sine is 5/13, up 5 over 13. So I know the sine of theta equals 5/13. That's my given. I know that it lies in quadrant 2. So based on the information, can I find out what each of these double angles are? So let's give it a try. Let's see what we can discover here. First of all, it looks like that I need to know sines, but I got to also find cosines. And so cosines in this particular case is this length right here. So I can use my Pythagorean identity or triangle to know what that side is, and this side is 12, and it's in the negative distance. So I will use a negative 12 for my value input that I have. And so the cosine of theta then is adjacent over hypotenuse, which is minus 12 over 13. And then tangent. The tangent of theta I will also need to work through. And the tangent of theta was sine over cosine. And so that becomes sine, which is 5/13, all over minus 12/13. And that reduces down to 5 over negative 12. Or I can look at it over here. The tangent of theta is its opposite over its adjacent, which was 5 over negative 12. And so both ways I was able to discover what those were. So let's use those things that we are starting to build and solve the next problem. So the sine of 2, the sine of 2 theta equals 2 times the sine of theta, cosine of theta, and the sine of theta, let's have 2. The sine of theta, we know the sine of theta is 5/13. The cosine of theta is minus 12/13. And I just need to multiply those out. So 2 times 5 times minus 12 gives me minus 120. All over 13 times 13 is 169. And they don't look like they reduce right away. And checking my work earlier, nope, they do not reduce. So let's look at the cosine of 2 theta. That becomes cosine squared of theta, and cosine was minus 12/13. And we're going to square that. Minus sine squared. Sine was 5/13. minus a minus 5/13 and square that. No, it's a positive 5/13. Sorry, folks. Minus 5/13. I just had this extra line that was just messed me up right there. So 5/13. So let's work out the work. 12 squared equals 144 over 169 minus 25 over 169, and that equals 119 over 169. 25 minus, yep, drop my remote. And the next one that we're going to look at is the tangent of 2 theta. Tangent of 2 theta we discovered is 2 times the tangent of theta. So 2 times the tangent of theta, we found the tangent of theta was minus 5/12 all over 1 minus the square of that tangent. And let's work that out. So 2 times negative 5 gives me a negative 10 over a 12. 1 minus the square, that gives me a 25 over 144. Let's get a common denominator for this one. So let's multiply this side by 144 over 144. So now I have 144 minus 25 on the numerator, minus 10 over 12, all over 144 minus 25, which is 119, all over 144. Let's flip and invert so that I'm going to come over here, guys. So minus 10 twelfths times 144 over 119. I can reduce this down to 5/6 times 144 over 119. Looks like 6 goes into 144 26 times. Minus 5 times 26 gives me 120, a negative 120, all over 119. And so that's the double angle formula, or that's the double angle value for tangent.